Hi, I'm Dr. Tara Armstead, and I am a nursing professor here at Muskingum University, and I just want to share with you some things that happen in our simulation lab. We are fortunate here at Muskingum University to have high fidelity simulators in our lab and give the students that come to Muskingum the opportunity to see firsthand what a clinical setting is going to be like. This is one of our high fidelity simulators. This simulator has opportunity to teach multiple different body systems, to teach prioritization of different types of care that patients are going to receive out in the clinical setting. As you can see, this patient is blinking, so neurologically he has some neurological function. You can see that his chest is rising and falling, so he has the physiological response to be able to breathe, so that the students can actually look at the patient, count the respirations, and see if they are really breathing. We have the opportunity through our high fidelity simulators to be able to show real patient monitoring and assessment devices also. We simulated a real scenario that the patient had come into the hospital and they had been there for 2 days. They had received a gunshot wound to the left side of the chest. The patient was stable, was doing better. And then the patient was complaining of pain, so we had an order from the physician to administer pain medicine. So we saw the students administer the pain medicine. However, after they administered that pain medicine, the patient started to deteriorate clinically. They got to be able to see the heart rate go down, they saw the pulse oximetry drop, and they knew that clinically that they needed to do something different with clinical judgment and critical thinking skills that we're able to teach through this type of simulation.
Hi, I'm Kathleen Jeffers. I'm one of the nursing faculty here at Muskingum University. And today I'm going to show you some of the state-of-the-art technology that we use when we educate our nursing students. So I want to show you our anatomage table. Our anatomage table actually has virtual cadavers inside. So the anatomage table can be used for some of the simplest concepts in nursing and some of the most complex concepts in nursing. So one of the things that we did explain to our sophomore nursing students, we were talking about diversion when we have a bowel movement. So we were talking to them about taking care of a colostomy. So we can talk about taking care of a colostomy on a mannequin, but if we use something like the anatomage, they can actually see inside the patient and understand what they need to look for when it comes to complications, what's abnormal, and what's normal. So what we do is we can actually go in and choose that specific body system. So if we want to look at the digestive system, we take away all the other body systems, and then we can even go further and choose the specific organs in the digestive systems that we want to see. What is so helpful having this state-of-the-art equipment for our nursing students is instead of learning about task-oriented nursing, they are actually able to critically think, they're able to pull this all together and totally understand if this patient is having a procedure, this is what I need to do as a nurse to watch for that patient, to make sure that that patient is stable. So they don't realize I'm just getting a set of vital signs, but they understand if my patient had this procedure and somebody is doing this to their body, I need to watch their heart rate because they could be bleeding. I could be watching their blood pressure because they would be bleeding. So it's almost the why behind it. And it's not a mannequin, it's not a textbook, but they can see what potentially could be going wrong or the things that could be fixed in the body during a procedure.
Hi, I'm Dr. Richard Taylor, and I'm a faculty member in the Department of Physics and Engineering. I'm here to provide an overview of the computational skills that our majors will receive. Students begin with sensor-based data acquisition and techniques for fitting data for the purpose of comparing their theoretical predictions with their experimental results. They then learn how to program and apply numerical methods so they can solve problems and visualize their solutions. They also apply their programming skills to interface with external electronics to develop their own mechatronic or measurement systems. They begin to use simulation software as the scope and/or complexity of the problems increase. They now have the responsibility of making sure that their inputs and their results make sense. In addition to further developing conceptual understanding, simulations become an invaluable tool for the design of new components, systems, or processes that meet desired needs. They simulate the behavior of analog, digital, and mixed circuits and choose appropriate components and configurations prior to circuit assembly. They perform computational fluid dynamics simulations to study fluid flows and analyze flow characteristics. They simulate mechanical structures, subject them to stress analysis, and choose configuration, materials, and joining methods prior to fabrication. We strive to provide our majors with the full range of computational skills that they will see in graduate school and in industry.
Hello, my name is Dr. Amy Santos, and I'm up on the 4th floor of Boyd Science Center in the biology department. And we have tons of equipment in the biology department, equipment that will be the same as what you'll find at a major research institute. One of the pieces of equipment that's been really helpful with our work with students and with classes is this DNA analyzer. So this DNA analyzer can perform DNA sequencing. So what that is DNA is made up of 4 different bases, A, C, G, and T. And we can literally look at genes or pieces of DNA and discover and do the experiment to learn what order these bases are in any given piece of DNA. In our molecular biology class, Biology 375, the students use this equipment. They get exposure to pouring their own DNA sequencing gel. They actually load their samples. They load their A, C, G, and T samples onto this gel, and then they're able to look at the data, look at the DNA gel. So this is an outstanding piece of equipment that allows our students to be able to learn the technique and know how it's being used in, yes, our experiments here, but experiments in journal articles they read. So what we have here is an inverted fluorescent microscope. So it allows for our students and research projects to explore cells while they're actually growing. So we can have cells in dishes. They can be growing. We can take a look at the fluorescent properties of the cells and then put them back in the incubator, regrow them, and then come back and monitor them from time to time. So this allows for us to do real-time experiments here at Muskingum University. We can also fix our cells and look at samples that are processed or at the end of their processing, like the slide that I have up here on the stage. And what it allows us to do is identify the specific location of particular proteins and different parts of the cells. Students in Biology 336, cell physiology, will be using this technique in order to look at the size, the shape, the dimensions of mitochondria in response to different treatments. So students at Muskingum University are exposed to this level of sophisticated research within their laboratories, and they're also able to use this sophisticated equipment to explore research projects, allowing them to fill up their resume and also help them understand what direction they want to head in life if they want more of this.
Hello, I'm Dr. Lois Zook, and I am a professor of chemistry at Muskingum, and I'm also the director of our environmental science program. And the instrument that we're in front of right now is an atomic absorption spectrometer, and it can be used both for chemistry and for environmental science projects, because what it does is it measures metal concentrations. So it has a lamp. The lamp shines a light through a flame. And so we've got this flame here, and our sample gets sucked up through this atomizer, and the sample goes into the flame. And if it has metals in it, the metals get excited by the flame, go into their atomic state, and then the light hits them. The more light that's absorbed, the more metal you have in your sample. In this particular setup right now, we have a chromium lamp in there, and so it will tell us chromium metal concentrations. Chromium is an environmental hazard if it's in your water or your soil, so it's important to know if you have chromium concentrations that are too high for the EPA limits. One of our students right now is studying water samples in the New Concord area to see if there's chromium and other heavy metals in the water. Last year we had a student who was looking at metals that fell into the soil as a function of fireworks shows. And so he was really interested in metal contamination of soil, and this instrument allowed him to study that and found that barium concentrations were pretty high in the soil around fireworks displays. Our environmental science students and our chemistry students can use this instrument to look at various metals, whatever environmental issue they have a concern about.
I'm Jay Shaftstall, and I teach in the computer science department here at Muskingum University. And this is some of our virtual reality and augmented reality equipment that we have for students. So this is the Microsoft HoloLens. This is augmented reality. So it overlays a computer screen on what the user sees in the real world. Students can do things with this. They can create repair manuals for cars if they want to. So you could overlay onto an actual, what they're seeing of the engine, the labels for what everything is. The International Space Station has one of these for just that sort of thing. And then this is our virtual reality equipment. This is an Oculus Rift, and students can run 3D games in this. We have a 3D gaming class, and students in that class can then try to run their games in the virtual reality and see what it looks like when they're actually there. So as students get out and get into careers, augmented reality and virtual reality are big players these days. Lots and lots of companies are getting into it, and having this sort of experience is going to be a big benefit for them going forward. And it's a great thing to put in your resume, something that a lot of students won't have.